In this video, we're going to look at computing or recomputing traverses. Let's go all the way back up to the top of this traverse. And remember, we said earlier that we have the raw data available to us. Okay, back up here and select one of these points. So here I'm looking at the raw data. If I do Shift F9, which is the hotkey, I'm back to looking at the inverse data based on the computations. So anytime I want, I can go to Tools, Recompute, and Traverse PC will start at the top of the traverse and recompute to the end. Now, if I've done adjustments to this traverse, they're going to be undone because I'm recomputing positions based on the raw data that's stored for each point. So I'm going to choose Yes. Now, when this traverse was imported from the data collector, if we go back up to Format and Format View, Traverse PC said, I'm going to match the computation system used on the data collector, grid distance and grid bearing. So if I come back to this traverse and check any inverses here, these are going to be based on the grid computations. So I'm going to show you how to do that first from the point view, and I'm going to check 8 and 8:1. Okay, 8:1 was the data collector's position for this point, and 8 is the geodetic control point that we started with. I'm going to select these in the point manager, and then from the toolbar up here I'm going to choose random inverse. And Traverse PC says those are 31/100ths apart. Now watch what happens if I come back to the traverse view and I say View, Format View, and this time I say let's work with a ground distance at the project elevation of 3800, and we'll leave the grid bearing on there for now. Okay. Initially, Traverse PC displays the ground distance without doing any computation. So this slope distance is now, or would basically be the equivalent based on a ground distance at 3,800 feet. If I were to choose Tools Recompute, Traverse PC now has the opportunity to update the coordinate positions based on the distance being a ground distance and not a grid distance. And if we go back to points, pick our 2 points, and go to random inverse again, I see that now I have just 1/10 of a difference between those 2 points instead of 3/10. So I've actually improved my closure potentially by simply switching to a ground distance versus a grid distance. And I would expect that in the computation of these traverses. Now I can go one step farther, and I can say not only do I want to use a ground distance, but I want to switch to a true bearing and use mean course convergence. Now this really isn't going to affect it too much because we're turning angles and not bearings, but I want you to see what happens here. That again, I can choose Tools, Recompute. Let's go back to our point view and go to random inverse. So really it didn't change our inverse distance between 8 and 8:1, and we really would expect that because the bulk of that difference is just the distance factor associated with this state plane coordinate grid and the fact that we're shooting these shots at a project elevation of 3,800 feet instead of mean sea level. So I might be more comfortable closing out this random inverse, going back to the view, and saying I'd like to use a ground distance, either a geodetic or planar, however you want to define that, and would be just as happy to use ground distance and a grid bearing here and compute it that way. The choice is really yours, but I would encourage you, if you have a significant project elevation, to consider using a ground distance or a geodetic distance instead of a grid distance initially. Now, ultimately, if we do a least squares network adjustment on this, Traverse PC goes back to the raw data for each observation, and so it really doesn't care that much what coordinates got computed during this recompute option. It's going to adjust the coordinates for us based on the least squares network. So it has a little impact on the least squares adjustment that we'll do in a future video.